Have you ever found yourself wishing your business software could just, well, take initiative? Not just answer a quick question, but actually understand a complex goal and then go execute it all on its own. Because the world of AI is moving incredibly fast. It's really far beyond the chatbots we're all pretty familiar with now. Today, we're doing a deep dive into Microsoft's very latest 2025 technologies. We're talking about building truly powerful, autonomous AI agents specifically for businesses. So our mission today is really to demystify how these intelligent agents are built, what kinds of real-world problems they're actually solving, and how they're looking set to reshape the enterprise as we know it. And the scale here, it's already huge. Azure AI Foundry, which powers a lot of this, supports over 70,000 customers. Get this. It processed 100 trillion tokens last quarter. And it handles something like 2 billion enterprise search queries every single day. Okay, let's unpack this. There's just so much happening with AI agents, and today we're cutting right to the chase with the latest from Microsoft. So first things first.
To really grasp what we're discussing, we need to be clear on what an AI agent actually is. Because it's fundamentally different from, say, an assistant. An assistant, well, it supports people, right? Answers questions, finds info. But an agent completes goals.
Exactly. We're talking about a pretty significant leap in autonomy here. Agents can make decisions, they can invoke various tools, participate in complex workflows. Sometimes they do it independently, sometimes they work collaboratively with humans or even other agents. That autonomy, that's really the key differentiator. And, that autonomy isn't just magic. It's actually powered by a really well thought out 3-tier architecture inside each Azure AI agent. So at the base, you've got the model layer. Think of this as the agent's brain. This is where the large language models, the LLMs like GPT-4 or GPT-4, maybe GPT 3.5 from Azure OpenAI, or even open source ones like Llama. That's what provides the core reasoning and language understanding.
Okay, the brain. Makes sense.
And what's really neat about this layer being modular is you can swap out the brain. As newer, maybe more powerful models come along, you can upgrade without rebuilding the entire agent structure.
Ah, flexible. Good.
Then, sitting above that is the instruction layer. This is where you really define the agent's purpose, its goals, its behavior, any constraints it needs to follow. You can encode specific knowledge for its role here. And interestingly, you can even teach it patterns from past successes using real conversation data and tool results.
So you can tailor it very specifically.
Precisely. Highly customized for a particular business function. And finally, there's the tool layer. This layer gives the agent its hands, essentially, its ability to interact with the world. This lets it retrieve knowledge maybe from internal SharePoint or the web via Bing or specialized systems like Azure AI Search. But crucially, it also lets it take real-world actions through integrations with services like Azure Logic Apps, Azure Functions, or really any service with an open API interface.
That distinction, agent versus assistant, it's so important. And it really points to the tangible business value, doesn't it? I mean, we're not just talking about cool tech here. Businesses want automation that's faster, more accurate, and ultimately frees up their people, their most valuable asset.
Yep.
Imagine an agent summarizing massive reports, processing invoices perfectly every time, managing support tickets from beginning to end, maybe even drafting and publishing blog posts. The goal is always shifting people to higher value, more strategic, maybe more creative work.
And we're already seeing some pretty powerful results. You mentioned case studies.
Yeah.
Fujitsu is a great one. They used Azure AI Agent Service, along with Semantic Kernel, to build an agent for creating sales proposals. The result, a 67% boost in productivity.
Wow, 67%.
Yeah, that meant their sales teams could spend way more time actually talking to customers, engaging them.
That's huge. And Cineplex, too.
Right, Cineplex, the Canadian entertainment company, they completely revamped their refund request process. Used to take 5, maybe 15 minutes for each request.
Yeah.
Now it's largely automated by an agent. Think of the time saved there.
Huge efficiency gains.
Beyond just those single tasks, these agents show some really impressive perception and reasoning. They can handle unstructured inputs like a user prompt, sure, but also maybe an internal system alert or even a message from another AI agent. And then they intelligently process that, calling tools as needed to get more info or trigger actions. It enables much more complex decision-making than just a simple Q&A.
Okay, and here's where it gets really interesting for me. It's not just about these isolated tasks anymore, right?
Mhm.
We're starting to see actual collaborative intelligence.
Mhm.
Like you could have multiple AI agents working together on something complex. Maybe one agent gathers the data, another analyzes it, and a third makes decisions based on that analysis,
Yeah.
forming a whole sophisticated system.
That's exactly the direction things are heading. It's less about a single tool and more about an ecosystem of collaborating agents.
That really feels like a game changer.
It is. What's truly fascinating here, I think, is this fundamental shift. We're moving from AI that just provides support, answers questions,
Yeah.
to AI that can autonomously complete complex goals. It's not just a small step. It's really redefining what AI can actually do within a business context. It goes from being a helpful tool to being an active participant in core business processes.
Okay, so building these advanced agents, it's clearly more than just picking an AI model. You need a solid, integrated infrastructure underneath it all. And that seems to be where Azure AI Foundry comes in. It provides this unified experience for developers, for building, testing, deploying these things.
That's right. Azure AI Foundry effectively pulls together capabilities from a bunch of different Azure services into one place for the developer. The core setup really revolves around three essential components. At the top, you have the Azure AI Foundry Hub. Think of it as the main control center, and it's actually built upon the Azure Machine Learning Service.
Okay, the hub.
Then within that hub, you create your specific Azure AI Foundry projects. These are like child resources where your actual agent development happens. And when you set up a hub, it also automatically provisions some necessary dependent resources, things for data storage, secure model access, the compute power your agents need to run. It handles that setup for you.
Right. And for businesses needing really fine-grained control, you mentioned there are different setup options.
Yes, there's a key choice there. You've got the basic setup. This uses Microsoft managed resources, multi-tenant search and storage. It's simpler, maybe quicker to start, but you have less direct control.
Okay.
Or you can go for the standard setup. This uses your own customer-owned single-tenant resources.
Oh, so you manage it directly.
Exactly. Full control, full visibility over your data, your operations. It does mean you incur the usage costs for those resources directly, but for many enterprises, that control is crucial.
And that standard setup has a new feature for 2025. Something about storage.
Yes, a really important one. It now supports bring your own thread storage, or BYO thread storage, using Azure Cosmos DB for no-sol. What this means practically is businesses can store all the conversation history, all the operational logs from their agents directly in their own Cosmos DB account.
Ah, okay, so complete data ownership and governance.
Precisely. It offers an unparalleled level of control, security, and helps meet strict data residency requirements. That's paramount for many large organizations.
This all seems to tie into a pretty robust security and compliance framework overall. You've got identity through Microsoft Entra, role-based access control, content filters, encryption, network isolation. It feels very enterprise-ready.
It absolutely is. Foundry builds on Azure's existing enterprise-grade security posture, and that choice over infrastructure, platform managed, or bring your own reinforces that commitment to trust and flexibility.
Yeah, that raises a really important point, doesn't it? For big companies, security, data control, compliance, these aren't optional extras. They're table stakes.
Foundational requirements, exactly. The ability to manage your own thread storage, your own infrastructure, provides that critical layer of trust. And speaking of control, permissions matter too. Anyone actually building or editing agents, say in the agent playground or using the SDK, they need the built-in Azure AI Developer RBAC role.
Okay.
That gives them the specific permissions to read, act on, or delete agents. And for deploying the underlying infrastructure templates, you generally need a higher-level admin role, like role-based access administrator or even owner at the subscription level, just to ensure proper governance.
Right. So we have the infrastructure, the security. What does it actually look like to build one of these agents? How does it all come together? You said it feels like a finely tuned machine, brain to execution, and the source material used that great analogy, like an assembly line.
Yeah, think of Azure AI Foundry as an assembly line for intelligent agents. I think that captures it really well. It brings together the models, the tools you need, the policies for behavior, and the orchestration logic to build agents that are not just smart, but also secure, testable, and genuinely ready for production use.
So walk us through that assembly line. What are the stages?
Okay, so there's a predefined 6-stage production pipeline. It starts with the model selection stage. This is where you choose that core LLM, the brain. GPT-4o, maybe Llama, whatever fits your need, that's the reasoning engine.
Got it. Pick the brain.
Then comes the customization stage. Here, you shape that general purpose model for your specific use case. This might involve fine-tuning on your data, distillation, or crafting really specific prompts. You can even encode successful behaviors learned from past agent interactions. This makes it understand your business context.
Tailoring it. Okay.
Stage 3 is tool integration, equipping the agent with its hands, giving it access to the tools it needs, maybe Bing for web search, SharePoint for internal docs, Azure AI search, and importantly, tools for taking action like Logic apps or Azure functions.
Even get capabilities.
Exactly. Then stage 4, orchestration. This is where the coordination happens. Managing the agent's lifecycle, how it handles tool calls, updates its internal memory or thread state, retries if a tool fails, logs everything it does. This ensures it acts robustly.
Keeping it all running smoothly.
Precisely. Stage 5 is trust and security. This is where those enterprise features we talked about, RBAC, content filters, encryption, are applied to make sure the agent is reliable and safe for business use.
Critical checks.
And finally, stage 6, observability. This is the final check and ongoing monitoring. Agents are thoroughly tested before deployment and then continuously monitored in production. We capture logs, traces, evaluation metrics at every step. You get full visibility right down to the individual conversation thread, and it integrates with application insights for that continuous improvement loop.
That sounds incredibly thorough. A structured pipeline like that must really speed things up and reduce errors compared to, just winging it.
Oh, absolutely. It accelerates time to production significantly and builds in that enterprise-grade reliability from the start.
And looking ahead, you mentioned 2025 is bringing some revolutionary features to this agent factory.
Yeah, some really exciting developments. First, there's the public preview of deep research in Azure AI Foundry. This is basically an API and SDK for OpenAI's advanced agentic research capabilities.
What does that mean in practice?
It means agents can now perform really deep planning, analysis, and synthesis of complex information, especially from the web. Think about tasks that might take a human researcher days, complex market analysis, scientific literature reviews. Agents can automate significant parts of that now, and crucially, generate auditable output so you can see how they reach their conclusions. It's a major leap for automated knowledge work.
Wow. Okay. That's powerful. What else?
Agents can also now extend their reach using the new Model Context Protocol, or MCP tool. This lets them connect to and use tools hosted on remote MCP servers.
MCP Model Context Protocol. Why is that significant?
It's a big step for interoperability. It means agents aren't limited to just the tools directly integrated within Azure AI. They can potentially call out to tools running elsewhere, maybe even in other clouds or on-premise, as long as they adhere to this protocol.
Breaking down silos. Nice.
Exactly. And for anyone working with data, the Microsoft Fabric tool is now available. This lets users interact directly with their data in Microsoft Fabric using a chat interface, essentially querying and analyzing Fabric data through conversation.
Very cool for data teams. And how about deploying these agents? Is it flexible?
Yeah, there are different approaches. You can have statically defined agents. These are deployed like a typical microservice. Their logic, their data sources are all configured at deployment time. They're stable, predictable, good for controlled DevOps processes.
Okay, the traditional approach.
Or you can use dynamic agents. These can actually be created or modified at runtime using the Azure AI Agent SDK. This means you could spin up new agents on demand or reconfigure existing ones based on changing user needs or business logic without needing a full redeployment. Offers incredible adaptability.
That dynamic approach sounds really powerful for evolving needs. Now let's shift gears slightly and talk about the core frameworks Microsoft offers for building these agents. Semantic kernel and Autogen. It sounds like they're working much more closely together now.
They are, yes. There's a clear roadmap for deep collaboration between semantic kernel and Autogen, aiming for the best possible experience for developers. The way to think about it now is, semantic kernel is really geared towards building robust, enterprise-ready applications that need production support. Autogen, coming out of Microsoft research, is fantastic for rapid experimentation, exploring those cutting-edge multi-agent patterns, really pushing the boundaries.
So different strengths, but converging.
Exactly. The goal is closer alignment by early 2025. But the key message for customers right now is, if you need to build something for production today with full enterprise support, semantic kernel is the way to go. And in fact, semantic kernel's own agent framework is now generally available, or GA.
Okay, GA, that's a big milestone.
It is, and it's specifically designed to simplify orchestrating multiple agents together and, crucially, to dramatically reduce the amount of boilerplate code developers have to write. big productivity win.
That's always welcome news for developers. And semantic kernel supports different ways for these agents to work together, these orchestration patterns. Can you break those down?
Sure. There are 5 core patterns they highlight, each suited for different kinds of tasks. First is sequential orchestration. Think of it like a classic assembly line. Agents are called one after another in a strict order. The output of Agent 1 feeds into Agent 2, and so on. Ideal for workflows where steps depend on each other.
Linear, predictable. Got it.
Then you have concurrent orchestration. This is more like having multiple specialists working in parallel. Several agents run at the same time, maybe gathering different pieces of information independently, and their results are collected as they finish.
Faster for independent tasks.
Okay. Third, and this is really central to both semantic kernel and autogen, is group chat orchestration. Here, you have an agent chat object that manages the shared conversation history. It acts like a moderator in a team meeting, deciding who speaks next based on the flow of the conversation and the agent's roles. It allows for much more dynamic back-and-forth interactions.
Like a real team discussion.
Exactly. Fourth is handoff orchestration. This is really important for scenarios needing human-in-the-loop, or HITL. An agent might reach a point of uncertainty or need approval for a sensitive action. It can then pause and explicitly hand off the task to a human user for feedback or a decision before potentially resuming. Ensures human oversight when needed.
Crucial for safety and control.
Absolutely. And finally, there's agentic orchestration. This is often used for more complex problem solving. You have a manager agent that breaks down a large task and assigns subtasks to specialized worker agents, maybe one for research, one for writing blind, one for analysis. The manager coordinates their work, gathers their findings, and synthesizes the final result.
So like a project manager with a team of specialist agents.
Precisely. While sequential is good for simple workflows, for really complex enterprise problems, group chat and especially agentic orchestration offer tremendous power by mimicking how expert human teams collaborate.
That makes sense. And on the autogen side, it's more research-focused open source.
Right. Autogen comes from Microsoft Research's AI Frontiers Lab. It's an open source framework designed to simplify building these often complex, event-driven, distributed agent applications. They recently put out a pre-release of Autogen 0.4. It's described as a ground-up redesign. The focus is on an event-driven architecture that's X-language, meaning it aims to work across different programming languages and also composable, flexible, highly observable, and scalable. That distributed capability.
Okay, so pushing the research frontier. How are semantic kernel and autogen actually integrating? What's the strategy?
It's a smart, three-pronged approach. First, they're creating a shared runtime repository. The idea is to develop common packages and abstractions that work seamlessly across both frameworks. Less duplication, more consistency.
Makes sense.
Second, this shared runtime can be hosted flexibly. You can run it in process within your application, or for bigger scale, deploy it on distributed system frameworks like Dapper or Orleans. Gives developers options. And third, critically, connector integration. Semantic kernel is actively adding connectors to allow its orchestrator to manage agents built with other services. This already includes things like OpenAI assistants and Azure AI agents, and now it's adding support for integrating autogen agents too, starting with Autogen v0.2.
So semantic kernel can orchestrate autogen agents as well.
Exactly. If we connect this to the bigger picture, this convergence is really about giving developers the best of both worlds. Unparalleled flexibility and power, whether they're building robust production systems with semantic kernel or exploring the absolute cutting edge of multi-agent research with autogen.
Right. Okay, so we have these powerful frameworks. Let's talk about weaving agents into really complex business workflows and enterprise patterns. This idea of a connected agents architecture sounds key. Agents calling other agents.
Yes, that's a core concept. Instead of just being isolated tools, agents can actually invoke each other as if they were just another tool in their toolkit. So you could have a planning agent call a research agent, which then calls a writing agent, passing the task along. This allows for collaborative problem solving on really complex issues.
And these multi-agent workflows, they can handle long-running processes too, like things that take days.
Absolutely. They provide a stateful layer. This means they can manage context over long periods, handle errors gracefully if one step fails, and maintain these complex, long-running processes. Think about things like intricate financial approvals that need multiple sign-offs, or maybe supply chain operations that span days or weeks. Agents can manage that entire flow.
That's incredibly powerful for core business operations. And you mentioned this isn't just locked into Azure.
Correct. Microsoft is putting significant effort into implementing open interoperability standards. Things like standard protocols for agent-to-agent, A2A communication, so agents built on different platforms can potentially talk to each other, and the Model Context Protocol, MCP, we mentioned earlier, for sharing contextual data consistently.
Why is that open approach so important?
It's critical for avoiding vendor lock-in. It means businesses can potentially build and integrate agents across Azure, AWS, Google Cloud, even their own on-premises systems, ensuring seamless collaboration wherever their data and systems happen to reside. It fosters a more open ecosystem.
Okay, let's make this really concrete. You gave the example of automating blog writing using multiple agents.
Yeah, it's a good illustration. Imagine orchestrating this with semantic kernel or autogen. You'd start with, say, a content collection agent. Its job is just to research the topic, maybe using Bing browsing to find relevant sources, and generate a solid outline.
Okay, step one, research and outline.
Then, that agent hands off the outline to a writing assistant agent. This agent, powered by a strong LLM like GPT-4o, takes the outline and writes the full blog post content.
Step two, draft the content.
Right. And finally, a content storage agent takes that finished text. It might use the kind interpreter tool within the Azure AI agent service to, say, format it correctly and save it securely to SharePoint, or a content management system ready for review and publishing.
A complete automated workflow. That frees up a lot of time for marketing teams.
Exactly. They can focus on strategy, topics, promotion, rather than the mechanics of drafting.
And integrating these agents into the wider enterprise. It sounds very flexible. Logic apps, Azure Functions.
Absolutely. You have access to over 1,400 connectors in Azure Logic apps to automate workflows across tons of different systems. And Azure Functions let you inject custom code, either stateless or stateful, for any unique logic you need.
And you can deploy them right into tools people already use. Teams, Office.
Yes, that's a key benefit. With just a few clicks, you can often deploy these agents directly into Microsoft 365, embedding them in Teams chats, Office applications, or even platforms like Slack or Twilio. It brings the AI capabilities directly into the employee's existing workflow.
Lowering the barrier to adoption.
Definitely. Now, another exciting area, especially for knowledge-intensive tasks, is a new feature in Azure AI Search called Agentic Retrieval Enhancement.
Agentic retrieval. What does that do differently?
Think of it as a smarter search engine, designed for complex, multifaceted questions. A standard search might struggle if you ask something really nuanced. This new engine uses an embedded LLM and the ongoing conversation context. It intelligently breaks down your complex query into several smaller, more targeted subqueries.
Okay, breaks it down.
Then it runs those subqueries in parallel across all your relevant data sources. And finally, it takes all those pieces of information and compiles them into a single, comprehensive, and importantly, cited answer.
So it shows its work.
Exactly. Early tests are showing really promising results, up to around a 40% improvement in answer relevance for these kinds of complex, multi-part questions compared to traditional methods. It makes finding the right knowledge much more effective.
That sounds incredibly useful. Okay, so we've built our amazing agent, maybe even a team of agents. Before we let them loose, testing must be critical.
Absolutely essential. You wouldn't deploy critical software without testing, and AI agents are no different, perhaps even more important given their autonomy. Azure AI Foundry really emphasizes a comprehensive testing framework. A big part of that is a robust pre-production evaluation strategy.
What does that involve?
It means using evaluation datasets, maybe curated examples of real user interactions, or specifically designed edge cases to really put the agent through its paces before it goes live. You assess its robustness, identify potential failure points, check its safety. It's that final quality gate to minimize risks and build confidence.
And you can use your own data for this, your own metrics.
Yes, that's a key flexibility. You can bring your own evaluation data. Foundry supports built-in evaluators for things like generation quality. Is the output good? Safety, is it harmful? But you can also define custom evaluators for metrics specific to your business goals. And you see all the results clearly presented in the Azure AI Foundry portal.
Then once it's deployed, how do you keep an eye on it? That's where Azure AI Foundry Observability comes in.
Precisely. It provides comprehensive monitoring capabilities, and it's seamlessly integrated with Azure Monitor Application Insights, which many organizations already use. This allows for continuous monitoring of your AI applications right there in production.
What kind of insights do you get?
There's a real-time intelligence dashboard. It gives you immediate visibility into critical metrics, things like latency, throughput, error rates, token usage, but also quality and safety metrics. This allows teams to spot and address any issues with performance, safety, or quality very quickly. For agents specifically, there are enhanced continuous evaluation features providing even deeper visibility into how they're behaving in the real world.
Now, you mentioned something really cutting edge for testing earlier, the AI red teaming agent. That sounds intriguing.
It is really innovative. It's currently in public preview. Think of it as an automated security tester specifically for your AI models and agents. Its job is to systematically probe your AI system, actively trying to find vulnerabilities, biases, or safety risks before attackers do.
So it's like hiring ethical hackers, but automated.
In a way, yes. It integrates Foundry's evaluation systems with Microsoft Security's Pyrite framework. That's the Python risk identification tool. It uses Pyrite to simulate complex adversarial attacks, trying to trick the agent, make it generate harmful content, or reveal sensitive information.
Wow.
It then generates detailed reports on the weaknesses it finds and helps you track whether your fixes are actually improving the agent's resilience over time. It significantly strengthens that pre-production risk assessment.
That feels like a crucial layer of defense, and this ties into the broader agent evaluation framework.
It does. Foundry Agent Service offers built-in evaluation capabilities. It can automatically assess things like, did the agent understand the user's intent correctly? Did it call the right tools with the right parameters? Is its output relevant, coherent, fluent? So you get these automated quality checks. And then the AI red teaming agent acts as this constant adversarial auditor, probing for those hidden vulnerabilities and biases. It's a multi-layered approach to ensuring agent quality and safety.
Okay, so we've tested thoroughly. Deployment time. How flexible is that process? Can developers use their preferred tools?
Very flexible. It supports development and deployment from various environments, GitHub code spaces, VS Code dev containers, or just your local machine. The key is that evaluation can be integrated directly into these local development workflows and, importantly, into your CI/CD pipelines.
Automated testing in the pipeline.
Exactly. Plus, you have those built-in monitoring and tracing capabilities via Azure Monitor and Application Insights, which makes troubleshooting and optimizing performance much easier once the agent is live.
And this all feeds back into improving the agent over time, a continuous improvement framework.
Yes, that's the goal. Azure AI Foundry has a core feedback loop system. It uses real-time telemetry and user feedback, combined with all the observability data, the evaluations, the traces, maybe results from A/B tests to give you deep visibility into how the agent is actually behaving. The new Foundry observability features provide that end-to-end monitoring with built-in metrics for performance, usage, quality, and detailed trace logs showing the agent's step-by-step reasoning.
So you can really understand why it did what it did.
Exactly. And this can all be integrated with GitHub Actions for CI/CD. You can automate evaluation runs as part of your pull request checks, for instance. The evaluation results even include things like confidence intervals and statistical significance tests, helping you make data-driven decisions about quality improvements. It also automatically tracks operational metrics like how long runs are taking, token usage, etc.
Very comprehensive. Okay, let's look ahead. Microsoft Build 2025 had some big announcements related to all this.
Huge announcements, really underlining the maturity of the platform now, the big one. Azure AI Foundry Agent Service is now generally available, GA.
GA. So fully supported, ready for prime time.
Exactly. It signals it's ready for widespread enterprise adoption, and the uptake is already significant. They mentioned over 10,000 organizations are using it, including big names like Heineken, Carvana, Fujitsu. They're automating real complex business processes with this today.
That's serious validation. What about the AI models themselves, the brains?
The model ecosystem is expanding rapidly. Grok 3 from xAI is available now in Foundry. Flux Pro 1.1 from Black Forest Labs is coming soon. And the one many people are excited about, Sora, OpenAI's video generation model, is also coming soon in preview via Azure OpenAI service within Foundry. So a much wider palette of intelligence for developers to choose from.
Sora in Foundry. Interesting. Now, what about the really experimental stuff, the things pushing the absolute boundary?
Okay, this is where it gets wild. Project Amelie. This is powered by something called RD Agent from Microsoft Research. Get this. It's an autonomous agent that can potentially build complete machine learning pipelines from just a single prompt.
Wait, what? You just tell it what you want.
Kind of. The example given was like, predict customer churn from this data set. And AMI aims to autonomously ingest the data, select features, train models, evaluate them, and produce a deployable ML solution.
That's AI developing AI.
Pretty much. It's still an experiment, but it shows the direction, automating the automation itself, truly pushing the boundaries of what agentic means.
Mind-blowing. Anything else on the experimental front?
A couple other interesting things. Agentic UI is an open-source experimental interface focused on human-centered interaction with agents for web tasks, trying to make interacting with these powerful agents more intuitive. And Type Agent is exploring how to give agents robust long-term memory, allowing them to retain knowledge and recall context over much longer periods, which is key for more complex, ongoing interactions or relationships.
Long-term memory is a big challenge. And for developers, any workflow improvements?
Yes, a big one. There's a new Azure AI Foundry extension for Visual Studio Code, now in public preview. This lets developers do the entire agent lifecycle: build, test, debug, deploy right within their familiar VS Code IDE. Less context switching, more streamlined workflow.
Developers will love that.
Absolutely. If we tie this all together, the big picture is clear. These innovations aren't just about making agents more powerful, though they are doing that. It's also about making them easier and faster to build, much more secure and reliable by design, and incredibly adaptable to the new, often unpredictable challenges that businesses face.
Okay, wow. We have covered an incredible amount of ground today. A true deep dive into Microsoft's 2025 vision for AI agents. We've unpacked how they're built, the real business problems they're tackling, and how they're set to transform the enterprise. To wrap up, the key success factors for anyone looking to leverage this powerful technology seem to boil down to a few critical takeaways from our discussion.
I'd agree. First, start with the right framework. Use semantic kernel if you need that robust, production-ready solution with enterprise support. Use AutoGen for exploring those cutting-edge multi-agent concepts and rapid research.
Right. Framework for the job. Makes sense.
Second, leverage the agent factory. Really utilize that structured, 6-stage production pipeline in Azure AI Foundry. It builds in security, testability, and reliability from the get-go.
Don't skip the process. Got it.
Third, implement comprehensive testing. Don't underestimate this. Use the built-in evaluators, bring your own data, and definitely look at leveraging the AI-read teaming agent to proactively find and fix risks before deployment.
Test, 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 especially with autonomous systems.
Fourth, plan it for scale. Think beyond single agents. Design your solutions with connected agents and those multi-agent orchestration patterns in mind from the start. That's how you'll tackle really complex, long-running workflows effectively.
Designed for collaboration and complexity.
And finally, fifth, monitor continuously. Once deployed, use Azure AI Foundry Observability. Keep a close eye on performance, quality, safety. Use those insights to continuously improve your agents. Production excellence requires ongoing vigilance.
Excellent summary. It really feels like the future of enterprise AI is shifting rapidly towards these agentic solutions, systems that can reason, collaborate, adapt, truly autonomously. So here's a final thought to leave you with. Think about your own work, your own professional life, maybe even a complex personal task. What's one complex, maybe repetitive, maybe just time-consuming task that could be fundamentally transformed, not just assisted, but truly handled by an AI agent that takes the initiative and autonomously achieves the goal? Where could that level of intelligent automation unlock entirely new possibilities for you or your organization? Something to ponder. Thank you so much for joining us on this deep dive into the really fascinating world of AI agents. We hope you feel more informed, maybe a little inspired about these powerful new capabilities and what they might mean. Until next time, keep digging deeper.